दोस्तों, आज की वीडियो में हम रॉकेट लॉन्चिंग टेक्नोलॉजी सीखने वाले हैं। चलिए शुरू करते हैं। रॉकेट एक ऐसा लॉन्चिंग व्हीकल होता है जो आर्टिफिशियली सैटेलाइट को अर्थ से स्पेस में लॉन्च कराता है।
Konstantin Tsiolkovsky, Herman Oberth, and Robert Goddard.
इन्हें मॉडर्न रॉकेटरी का फादर्स कहा जाता है।
The working of rockets is based on Newton's third law of motion and the principle of conservation of momentum. According to the principle of conservation of momentum, the total momentum of the system is conserved when the net force acting on the system is zero. Consider the following case. Let mass of a bullet be m, mass of a rifle capital M. Let the velocity of the bullet be v. Before firing, both the bullet and the rifle are at rest. So, total initial momentum is equal to 0. When the bullet is fired, the bullet leaves with a momentum equal to mv. The rifle recoils and moves with a velocity v. Total momentum after firing is equal to mv plus small mv. But we know that final momentum is equal to 0. So mv plus small mv is equal to 0. Or mv is equal to minus mv. So recoil velocity v of the gun is equal to minus mv upon m. A rocket works on the same principle. When a rocket is fired, the propellant burns and a large amount of gas is pushed out at high velocity. The ejected gas pushes the rocket with a high velocity in the opposite direction, and the rocket acquires an equal momentum. Usually, planes and other aircrafts use atmospheric oxygen for combustion, but rockets operate in space, hence they carry an oxidizer. The mixture of oxidizer and fuel is called propellant. The oxidizer releases oxygen that combines with the fuel to produce gas for propulsion. Propellants can be both solids as well as liquids. Solid fuels tend to produce lots of large particles and smoke. Thus, liquid propellants are used. Some rocket propellants are liquid hydrogen and liquid oxygen, kerosene and liquid oxygen, hydrazine and nitric acid, synthetic rubber or cellulose-based compounds and liquid oxygen, polybutadiene and acrylic acid with an oxidizer such as aluminum perchlorate. The mass of a rocket includes the mass of propellants, scientific instruments or the satellite in the rocket. The total weight of the scientific instruments or spacecrafts or astronauts that an aircraft carries to planets or space is called payload. The ratio of payload mass to fuel mass is called payload ratio. For a rocket, the acceleration of the rocket is determined by the amount of fuel burned and the escape velocity. Acceleration of a rocket is also affected by mass. For a rocket, the rate of fuel consumption multiplied by exhaust velocity is equal to mass of the rocket multiplied by acceleration. The practical aspects that need to be considered when a rocket operates are: the mass of a rocket goes on decreasing as it consumes fuel at every instance. As the rocket ascends, the acceleration due to gravity continuously changes. The lower stratum of the atmosphere offers resistance to the rocket. In a single-stage rocket, the total thrust is imparted in a single phase, either by a single or a multiple thrust unit. In this type of rocket, combustion takes place in the engine, and the exhaust gas comes out of the nozzle. The oxidizer and fuel are stored in separate tanks. But a single rocket cannot push an artificial satellite to a large height. In a multi-stage rocket, several rockets are joined together, one on top of the other, to provide necessary power. It uses 2 or more stages, each of which contains its own engines and a propellant. After certain heights, each stage of the rocket gets detached. This reduces the overall weight and also increases the efficiency of the rocket. The fuel consumption is also reduced in such rockets. The velocity of a satellite in a circular path is called the orbital velocity, VO. Centripetal force is needed for circular motion. If an artificial satellite is provided by the gravitational force of the Earth. Consider an artificial satellite of mass m going round in a circular orbit of radius r with velocity VO at a height h from the surface of Earth. Let the mass of the Earth be m. Then gravitational force Fg acting on the satellite will be equal to g multiplied by m multiplied by m upon r plus h whole square. Let it be equation 1. Here, g is the universal gravitation constant, equal to 6.672 into 10 to the power minus 11 Newton per meter square upon kilogram square. The centripetal force, FCP, required for circular motion of the satellite can be expressed as m multiplied by VO square upon r plus h. Let it be equation 2. From equations 1 and 2, we get m multiplied by VO square upon r plus h is equal to g multiplied by m multiplied by m upon r plus h square. So, VO square is equal to g multiplied by m upon r plus h. Or VO is equal to square root of g multiplied by m upon r plus h. When the value of h is too small compared to r, the former can be ignored. So VO is equal to square root of g multiplied by m upon r. Or g is equal to g multiplied by m upon r square, or g multiplied by m upon r is equal to rg. So, the orbital velocity in terms of acceleration due to gravity g is VO equal to root of gr. The minimum velocity with which a body must be projected so that it escapes from the gravitational field of the Earth is called escape velocity. Escape velocity VE can be calculated using the following formulae. For Earth, radius r is equal to 6.37 multiplied by 10 to the power 6 meters, and acceleration due to gravity g is 9.8 meter per second square. Here, escape velocity VE is equal to square root of 2gr, which is equal to square root of 2 multiplied by 9.8 multiplied by 6.37 multiplied by 10 to the power 6, which is equal to 11.2 kilometers per second. We know that orbital velocity VO is equal to square root of rg and escape velocity VE is equal to square root of 2rg. So escape velocity is equal to square root of 2VO.
फ्रेंड्स, कुछ समरी दी गई है, आप सभी इस समरी को ध्यान से लर्न कीजिए, इसे सीखिए। इस पूरे चैप्टर का ये बेस है हमारा। सो अगर आपको दोस्तों वीडियो अच्छा लग रहा हो तो वीडियो को लाइक कीजिए, चैनल को सब्सक्राइब कीजिए और इस वीडियो को अपने फ्रेंड्स के साथ शेयर कर दीजिएगा। बेल आइकन अवश्य दबाएं इस प्रकार के लेटेस्ट वीडियो सबसे पहले प्राप्त करने के लिए। ओके फ्रेंड, तो ये थी आज की हमारी रॉकेट लॉन्चिंग की वीडियो। सो मिलते हैं नेक्स्ट वीडियो में, तब तक के लिए बाय बाय।